Ever walked into your home and instantly caught the mouth-watering aroma of your favorite dish? Or stirred sugar into a cup of tea and wondered, where did it go? Maybe you've sprayed perfume and watched its scent magically fill the room in seconds. What if I told you all these everyday moments are tied to one incredible fact? Everything around you, the food, the air, even you, is made up of tiny, invisible particles. Welcome to the fascinating world of matter, and today we begin by uncovering its physical nature. So, what exactly is matter? In science, it's anything that has mass and takes up space. That's it. From the rock in your garden, to the water in your glass, to the air you're breathing right now, it's all matter. Even something as tiny as a grain of sand or as massive as a star far away in space still matter. But here's the real question: what's inside this matter? What gives it form, structure, or behavior? The answer lies in its tiniest building blocks, particles. Let's take a closer look. Here's a quick experiment straight from your book, and you can even try it at home. Take a beaker half filled with water. Now add a spoon of salt or sugar and give it a stir. What do you notice? The salt seems to vanish. But wait, did the water level rise? Not really. So, where did the salt go? It didn't disappear. Its particles simply slipped into the tiny spaces between the water particles. This simple observation reveals a powerful truth: matter is made up of particles. And these particles are so incredibly small, they can fit into spaces we can't even see. Amazing, right? All right, we know matter is made of particles. But here's a mind-blowing question: just how small are these particles? Let's explore this through a fascinating activity. Take a few crystals of potassium permanganate, that deep purple chemical, and dissolve them in 100 milliliters of water. Now take just 10 milliliters of that purple solution and pour it into another 90 milliliters of clear water. Repeat this 5, maybe even 8 times. What do you notice? Even in the last beaker, when the solution is incredibly diluted, you can still see a faint purple color. What does this tell us? That even a single crystal contains millions upon millions of particles, so small they continue to spread and color the water even when heavily diluted. That's how unimaginably tiny and powerful these particles are. Let's take a real-life example you've definitely experienced. Picture this: someone lights an incense stick in one corner of the room. At first, you catch the scent only if you're nearby. But soon, the entire room is filled with that soothing fragrance. Ever wondered why? It's because the particles of matter, in this case, the aroma, are so incredibly tiny and lightweight, they quickly mix with air and spread out. They're always in motion, constantly colliding and traveling, even when we don't see them. It's a perfect demonstration of how matter is made of active, moving particles. Let's take this concept a step further with a simple, thought-provoking numerical example. Here's the scenario: just 2 crystals of potassium permanganate can visibly color 1000 liters of water. Now, let's break that down. Step 1. Imagine each crystal breaking into trillions of particles spreading out in the water. Step 2. Even when diluted to just 0.002%, the solution still shows a faint purple tint. Step 3. What does this tell us? That particles of matter are not just extremely tiny, but also powerful enough to distribute themselves evenly, even in massive volumes. This numerical reasoning helps us visualize something we can't see: that the behavior of matter at a macro level is rooted in the invisible world of particles. Alright, let's bring it all together. Matter is made up of tiny particles. These particles are so small, they can easily fit between each other, and they're constantly on the move, mixing, spreading, interacting. You may not see them, but you feel their presence every day. When salt dissolves in water, when the smell of perfume travels across a room, or when incense slowly fills the air. All of these moments are powered by one fundamental truth: the physical nature of matter and its ever-active particles. Now that you've seen just how small and lively the particles of matter are, here's a question to tickle your brain. If air is made up of particles too, why does it sometimes feel light and breezy, and at other times heavy and humid? Could it have something to do with the number of particles packed into a space? Think about it. And stay curious, because in the next video, we'll dive into how these particles come together to form the three states of matter: solid, liquid, and gas.